Hello everyone, it's mershscore here. Today we're going to be solving for x in this nice exponential equation. 2 to the power sine squared x plus 2 to the power cos squared x is equal to 3. Before we begin, if you are new here, subscribe to my channel and also like the video. Now let's get started. First of all, let's record this important trigonometric equation. Sine squared x plus cos squared x is equal to 1. Now let's go ahead and then make sine squared x the subject, so that in place of sine squared x over here, we will replace it with the right hand side of this equation. So we're going to have sine squared x is equal to 1 minus cos squared x. So let's replace it here. The equation now becomes 2 to the power 1 minus cos squared x plus 2 to the power cos squared x is equal to 3. And from here, we can rewrite this as 2 to the power 1, which is still 2, divided by 2 to the power cos squared x, plus this one, we have 2 to the power cos squared x is equal to 3. Now, since this is not equal to 0, let's go ahead and then replace it with a certain variable. Let's call it m. So we have 2 to the power cos squared x is equal to m, where m is never equal to 0. So the equation now becomes 2 divided by m plus m is equal to 3. If we multiply through by m, we're going to have 2 plus m to the second power is equal to 3m. And this is also the same as m squared minus 3m plus 2 is equal to 0. Quadratic equation. So how can we solve this one? Using factoring method to solve this, we're going to have m squared minus m minus 2m plus 2 is equal to 0. From these two terms, we can take m out. So we're going to have m times m minus 1. Then from the remaining two terms, we can take negative 2 out, and we are left with m minus 1. And this is equal to 0. Now we also see that m minus 1 is common. So let's take it out so that we get m minus 1 times, here we are left with m, then this side we are left with minus 2. And this is equal to 0. Now at this point, we can say that m minus 1 is equal to 0, or m minus 2 is equal to 0. And now we see that m is equal to positive 1, or m is equal to positive 2. But remember, initially we let m equal to 2 to the power cos squared x, right? So when m is equal to 1, we're going to have 2 to the power cos squared x is equal to 1. And we can write 1 in so many ways, right? We can write it as 2 to the power 0. So we can see that the bases are the same, so we can equate their powers, right? So we're going to have cos squared x, let me write it well. Cos squared x is equal to 0. Now, if we take square root on each side of the equation, we're going to have cos x is equal to 0, because square root of 0 is 0, right? Now, let's come back to this equation when m is equal to 2. So, when m is equal to 2, we're going to have 2 to the power cos squared x is equal to 2. Now, this 2 is to the power 1. The bases are also the same, so we can straight away equate their powers. So we're going to have cos squared x is equal to 1. Now, taking square root on each side of the equation, we have cos x is equal to plus or minus 1. So what it means is that in all, we have 3 equations. We have cos x is equal to 0, cos x is equal to 1, and lastly cos x, let me write it here. Let me change the marker as well. And lastly, cos x is equal to -1. So we are going to focus on these three equations. Now considering this first equation, cos x equals 0 implies that x is equal to 90 degrees because cos 90 is equal to 0. But is that all the solutions to the problem? No, because x could also be 270 degrees, and also x can be 450 degrees. So all these solutions satisfy this equation, right? Now in radian, we're going to have x is equal to 90 degrees is also the same as pi over 2. Then 270 degrees in radian is simply 3 pi over 2. Then 450 degrees in radian is 5 pi. This keeps on going, right? So it means that we cannot find the definite solution for x. So let's write a general solution for this one. To get the general solution, we're going to multiply the minimum value here, which is pi over 2, by a certain odd number. So let's write the odd number as 2n plus 1 multiplied by the first answer to the problem, which is pi over 2, where n is an integer, right? It's very important. Yes, n is an integer. Okay, so now let's focus on the second value of x, which is this one. Cos x is equal to +1. So when x is equal to +1, if x is equal to 0 degrees, we're going to have cos 0, which is equal to 1. If it is 360 degrees, we will also get 1, and it keeps on going, right? So it means that from this equation, we have to also find a general solution since we have so many solutions. Now, in radian, this is still 0. Then 360 degrees in radian, that is 2 pi, right? So to get a general solution, we're going to multiply this one by a certain integer. So we have x is equal to 2n pi, where n is an integer, right? Then the last equation, which is cos x is equal to -1. Let me change the marker. Cos x is equal to -1. So from here, if x is equal to 180 degrees, we find a solution to the problem. Because cos 180 degrees is -1. If x is equal to 540 degrees, we also have a solution, and it keeps on going, right? In radian, 180 degrees is simply pi. Then 540 degrees in radian, we're gonna have 3 pi, and it keeps on going just like that. To get a general solution to this equation, we're gonna have x is equal to a certain odd number, which is 2n plus or minus 1 times the first answer here, which is pi. Now remember, n is also an integer. So basically, these are the general solutions to the problem. This is the first one, then this is the second one, and lastly, this is the third one. So this brings us to the end of this video. I hope you found it useful. Subscribe to my channel if you are new, and also don't forget to like the video, comment, and share. Thanks a lot for watching. Have a nice day, and see you again on the next video. Take care. Bye bye.